My name is Lucas Larson, and this is my presentation on the summer 2020 co-op rotation I completed at ATI Industrial Automation. This presentation is composed of an introduction section, a technical detail section, in which I'll walk through many of the projects and work that I was able to complete and had the opportunity to complete at ATI. And then finally a takeaway section in which I'll talk through some of the things that I learned and gleaned from the opportunity and many of the ways in which I developed because of it. So for summer 2020, the department I was in was the manufacturing engineering department. My co-op supervisor was Mark de Bordeaux. He is the supervisor of the manufacturing engineering department. And this was my first co-op semester completed. Some of the notable work that I had the opportunity to do and complete was I developed multiple tools to address continuous improvement projects. I designed tooling for improved component assembly. I created improvements through design and processes for the manufacturing floor. And I documented work instructions for new and existing electrical assemblies. So the first technical detail I'd discuss are the continuous improvement projects I had the opportunity to work on. This was a fairly significant responsibility within this role. Was addressing continuous improvement requests as they came from the floor. So manufacturing engineers work closely with the assembly line workers, and so if there's new product that they've been working to assemble and they realize that there's certain tools that may help them in different ways, there's certain processes that can be changed that can help them in certain ways, they'll fill out a continuous improvement request, and then it falls upon the manufacturing engineers to handle those requests and create solutions. So three of the big opportunities or projects I'd like to highlight are the GL utility coupler sensor setting block, PH4 tool, snap ring plunger, and a large QC collar plunger buttstock. So this first CI project, the guided cylinder sensor setting block, so the request was made to create a gauge to be able to measure the sensor depth on a GL guided cylinder before setting it in place. So up in the right picture, you can see the two sensors. They set at different heights due to the bolt that you can see on the furthest sensor. And the assembler had complained because it was difficult to get a set of calipers in there. He was really looking for a go, no-go gauge. So this was the first project I had the chance to do. And as you can see, the solution was fairly simple. Just this step block has a setting height on one side of 0.217, on the other side 0.447. Those are the sensor setting heights, and so requirements were to be able to set those heights within those tolerances to create something that's low cost and that had a small profile due to the spatial setting. So solution was to design the block that you can see there. So designed it, CAD model, created a drawing for it, and then requested the purchase of it. So the ATI machine shop produced that for us, and it was created, but don't know that it ever got to the floor yet, just as they haven't assembled any of these guided cylinder bodies. But the impact of this tool is meant to create a repeatable, easy way to set those sensor heights on the assembly. The next CI project I want to highlight is for this PH4 snap ring. So if you look at the assembly on the bottom right, you have these bolts around which a snap ring is placed in order to keep them in place. So the manufacturing assembly line lead had asked that they had a similar tube plunger to this for similar assemblies, and he was asking if one could be created in the same way. So as I looked over this problem, one of the things that I wanted to address was making something that was relatively low cost, that could be durable to repetitive, pushing on the end of the device, and then also create something that has some level of ergonomic comfort for the assembler to be able to continue pushing down. So I designed a what was a 3D printed cylinder tool with an ergonomic rounded press fit end. Um, and I had printed it out of a resin print in order to create greater rigidity, in order to have better durability. So again, this tool hasn't been used yet, just as these assemblies haven't come to the floor since it was made. It will greatly reduce the time and effort that was previously needed to set these snap rings on the assembly. The next CI project I'd like to highlight is this plunger buttstock for the large tool changer assembly line. So if you look in the bottom left image, there's this brass plunger being used on some of the larger assemblies that ATI is producing to push brass collars into place. And so as the assemblers use that, they press that back end into the bottom of their hand. The only way that they could go about doing that. So after repetitive use, it created a lot of pain in their palms. And so again, wanted to create something that had an ergonomic comfort to it that was low cost and durable. And so the solution was designing a 3D printed, what I call quote unquote rubber buttstock. It was dimensioned for palm fit. I call it a quote unquote rubber buttstock is because it was modeled from a thermoplastic polyurethane with a low mesh resolution. So it's 3D printed thermoplastic polyurethane with a low mesh in order to give it some give. So two of these versions were made, one for a larger of these presses, the 381020 1277, and one for a smaller 1204. The assemblers on the heavy-duty QC line, they all expressed relief that this part had supplied to their hands during assembly, and so hopefully it'll reduce assembly time as they're able to press more of these out faster. The next large and most likely the largest responsibility that I had in the co-op role was addressing different tooling needs for new products. Many of these requests came in the form of pin block dies for the pneumatic assembly of electrical module pin blocks. So we'll see a couple of those as I go through this. The projects highlighted are the AOV Media Hopper Spacer, the K12 Master Pin Block Die, the K26 Tool Pin Block Die, and the M Series Pin Block Die solution. So the first of these, this was the second project that I got a chance to work on. So again, a fairly simple tooling, but the material removal group, while I was in the manufacturing group, were just starting the release of their AOV media changer, which is a changer device for their material removal tools to be able to change out the tools on the master. So as we went through the NPI meeting, the new product introduction meeting, it was made evident that a spacer was needed to be created for a gap needed on the rail system that allowed movement on this changer. So the requirements was to create a gap of 0.078 plus or minus 10 thou, create something that was low cost and had an ergonomic shape so that it was easy to hold and maneuver in the space required. And so the solution, as you see, is this L-shaped sheet metal tool with a relief cut placed at the top that can be slid in between the bar and nut. I'll show you here in a second. The impact of this tool will be implemented shortly as this product is entering production. The tool should help assemblers being able to meet those spacing requirements for the bolt in question. So if you look at this assembly, you have this housing within which these are these extruded aluminum rails. If you look at this bottom small image, detail B, you see this 0.078 gapping. That gap is between the nut and, between the back end of this flange and the extruded rail here. So the goal is, as you see in the bottom right and top left, is to be able to place this spacer in between that space on both sides. And the gauge of this sheet metal is exactly the same requirement, 0.078 plus or minus 10 thou. So it should fit in there and give the correct spacing for the assembler. So the first of the pin block die projects that I had the opportunity to work on was the K12 Master Pin Block Die. The objective of this project was to design a set of tool dies in order to be able to pneumatically press the pin block assembly for the K-12 master pin block. So if you see this first image on the left, this small block in the middle of these two big parts, the 4942 and 4941, that's a pin block, which is used for electrical pass-through connection on ATI modules. The requirements for the pin block die, which is something used in a pneumatic press in order to be able to quickly press the pins into the small holes that you see on the top side of the pin block instead of manually pressing them with an arbor press. So the requirements would be to create a form-fit design in order for that pin block housing to fall into, create proper hole placement on the top die for push rods to push those spring pins into the top of the pin block hole, and then to create a low-cost solution. So designed for machinability, which is why you see these Mickey Mouse-like ears here at the top, as well as creating the most simplistic cuts possible. So the solution was to design a top and bottom set of dies, allowing for proper assembly of the pin block in the pneumatic press. So this required modeling the dies, creating CAD models, and then getting those models checked, and then creating drawings for those models, going through a drawing check, and then moving to a purchase request for the dies in order to get them machined at ATI. So if you look at the design of this, you have almost like three stairs. So the top ledge is meant to, on the bottom die, create a place for the pin block to rest, while the center cutout is meant to provide spacing for the pins to drop into as they're pressed into the top. Then you have the bottom shelf, which just creates a space for the bottom of the pin block to lie. And you've got these two relief holes for the pneumatic air to be relieved out of. And again, in the top die, you have the same exact pattern as what's seen on the top of the pin block. So required a good bit of geometrical tolerancing in order to make sure that everything matched up in the drawings. So the second pin block die here is the K26 tool pin block die. So again, have the same idea going on with the pin block. The objective is to design a set of tool dies for the pneumatic assembly of this K26 pin block. Again, you need a form-fit design so that the pin block stays in place as it's pressed. You need proper hole placement on the top die for the push rods, correct set screw tap depth for the longer push rods, low cost. And so in this assembly, one of these pins is a little bit higher when it's set than all the others, and so you have to have the correct tap depth on the top hole. Each of these top holes is drilled through for a dowel to go into and then tapped so that a set screw can set the depth of those dowels as they're pressed in. So as you see in this bottom right hand corner view, there's a form fit on this bottom die, allowing enough spacing for tolerance stacking so the pin block would in no way never fit within. And if you look at this bottom die, the top view, you can see a small dowel hole. That's for clocking, so there's a dowel hole relief in the pin block because it's anti-symmetric, and so you want to be able to set it in the right spot so that hole was placed in order to be able to do so. Again, for these pin block dies, top and bottom, these parts were modeled by myself, then had to review the models and then create drawings, review those drawings, and then push to production through a purchase request. The impact of these dies, the same as the last ones, is to be able to greatly reduce the assembly time of the K26 tool pin block. So the one larger tooling project that lasted the entire semester for the most part was working on these M-series pin block die solution. So the problem was that these M-series pin blocks are very small in their dimensions and in the holes in which the pin blocks, or in which the pins drop into, and very tight tolerances, many of which could not be held by the pin supplier. So oftentimes these pins were too large for the pin holes, and it wouldn't allow the installers to set the pins in straight and then press. And when you don't set them in straight, um, then when they're pressed into the nylon glass-filled pin block, then you can have the springs in the pins get damaged and they don't function correctly, and you lose continuity on your electrical connection. So the requirements for this project was to design a setting block in order to first place the pins in to keep them upright, and then be able to press the pin block on top of. Need to design a feature in that setting block that allows the assembler to set the solder cup direction. So each of these pins, if you look at the M8M, you can see on the bottom the solder cups. They have to be oriented in the correct direction, which is facing towards the opening. Then lastly, after designing the setting block, you need to design dies for the pneumatic press. So the solution I came up with was the design of a pin block dies with an insertable pin alignment tool. The pin alignment tool was designed with said feature to be able to allow for the alignment of solder cups. The impact of these tools is that it would greatly reduce the assembly time for these pin blocks and reduce pin failures that have occurred due to misalignment. So shown here is a solution for the ML8 and the M8M that I was able to design in my time with the manufacturing department over the summer. So you see here the ML8 is the insert for the ML8 and the insert for the M8M, and then I designed a universal die set. So this die set could be used with the 4 M series pin blocks that you saw on the previous side with their individual inserts. So each of the inserts was designed with the same bottom geometry, all of which can be placed in that bottom cutout that you see on the bottom die. The top die simply has a relief cut for the top of pins extruding from the pin blocks, and it just presses down around those pins on the top of the pin block. So if you look at these two inserts that I was able to design here, the ML8 has a form fit to the bottom end of the pin block. Then it has holes exactly lined up with where the pins are placed on the pin block. And if you look closely, you can see a small relief counterbore that the ledge of the pins are meant to sit on in order to keep them upright. Then the holes in the side are for that alignment feature for the solder cups. You're able to stick an M2 dowel in there and then be able to set the solder cups in the correct direction. You can see the same for the M8M pin block insert, a little bit more complex geometry on the top face, but the same idea there. Both of these were 3D printed first with a resin material in order to test with pin blocks. Adjustments had to be made in order to tighten up the edges so that no sticking occurred as these were pressed, as the pin blocks were pressed onto the inserts. But for each of these, the ML8 insert, the M8 insert, M8M insert, and the universal die set, I modeled these, reviewed those models, created drawings with GD&T, reviewed those drawings, and then created a purchase request for the ATI machine shop to make these products or these toolings. So all of this tooling has been created. It's ready for the manufacturing department to implement the next time that it's needed. Another technical work that I was able to complete was manufacturing floor improvement projects. So there were times during the rotation in which issues were highlighted on the manufacturing floor that needed to be addressed. These improvements were worked on in the hopes to decrease production times and improve the working environments. So some of those projects that I want to highlight here are the assembly line bushing gun update, the P80 container redesign, and the AMTI slice shroud. So if you look here, this is the manufacturing floor project, the bushing gun update. So the objective of this project was to update the 2 remaining bushing guns to match the latest design. So if you see here, you got the old design and the new design. These are used to pneumatically press rubber bushings into air ports on the tool changer bodies. So the old design required it's a much simpler design, but it required a little bit more input from the user, as well as it often got jammed um, as you're feeding the bushings in at an angle instead of directly dropping them straight down. They would often get caught as they transferred into the tube that would push them down. So the requirements was to take this new design and adapt the interior components in order to create a solution for the two remaining bushing gun upfits. And so within that, wanted to try to create the least number of parts possible. So the solution that I came up with, along with another manufacturing engineer and his help, was design a bushing gun that was similar to the new design, but it had identical parts. So for the remaining two bushing sizes, these new design parts could accommodate both of them, so that we wouldn't have to have three different bushing guns, but instead two, and one of which could be used for two different bushing sizes. So the impact of this bushing gun is these new bushing guns is to be able to reduce production time for these tool changers. These changes have not been implemented yet, as it's not the highest priority within the department, but it is something that is able to be implemented at any point. Another opportunity that I had was to work on the P80 container on the heavy-duty QC production line. So this again has some carryover with the previous project discussed, and the bushing guns. The bushings, as they're pressed into the QCs, get coated with P80 fluid, which is just a lubricant. So this container was on the QC line with pumps running down to these bushing guns. But the previous design had many flaws in which the top was being held on to this acrylic cylinder in which the P80 was contained, with zip ties that were pressed against the edge of this bottom the retainer and against the top 3D printed part. And so every time that someone would attempt to refill, they would have to slide off the zip ties and then open up the container. And when they did, any P80 fluid that was left at the bottom would immediately leak out because all pressure was lost, keeping that acrylic tube down. So the requirements was to design a new P80 container with a much improved clamping function, and then to create a feature that allowed for easy pouring of the P80 fluid. So the solution that I designed, these parts were all 3D printed, was a new container top that was based off of the old one, but I included these flanges that can be seen on the outside with holes for an M4 by 5-inch bolt to run through, along with creating a spout on the top side, threaded spout that could allow the assemblers to pour in the P80 fluid from the top without having to remove this entire top structure. They simply have to unscrew the cap. And one of the things that I encountered is I had a previous iteration of this bottom clamp that was a little bit too flimsy, so I had to redesign it with these wedge flanges in order to create something a little bit more robust, so that it would hold the pressure that was being applied by these two bolts on either side. So this design has created less headaches on the floor due to eliminating P80 leaks from the container, and it reduced the difficulty of refill. So just helping the assemblers out, reducing the time that they have to deal with aches and pains and having to clean PAD off their hands or off the floor, whatever it may be. Last manufacturing floor project that I wanted to highlight was this AMTI slice shroud that I designed, had manufactured. So the problem that was occurring was on the electrical bench assembly, they had this wire cutter to cut numerous amounts of wire for different electrical assemblies. That as it was running, it just creates a good bit of noise, to which the assemblers in the area had been annoyed by for some time. So I was asked to try to come up with a simple, cheap, low-cost noise reduction solution. Had to accommodate for wire entry along with an air port and a power cord. So I ended up designing a three-piece sheet metal shroud that had two doors. So as you can see here, you have the top door with a handle on it, and then the smaller door with a little latch on it to keep it locked. So you could open the big door, the smaller door wouldn't fling open. You can feed wire into the back end of the wire cutter, and you can close that big door in order to maintain some of your soundproofing, and then open the smaller door in order to put in your settings for the wire cutting operation. So the interior of this was dampened with sound reduction material, different foams and padding, and the shroud has reduced the decibel levels by over 50%, so cut them in half. And this is something that's passed on for me as I'm not there anymore, but they were looking to beef up the foam padding slightly in order to increase that decibel level. So another technical detail that I wanted to highlight was just the copious number of work instructions that I had completed while I was in the manufacturing department. So at times during the rotation, there were either new products or new assemblies that had to be evaluated or optimized, and these assemblies needed documentation. So as process engineers were putting together new assemblies, there were either difficulties or just documentation that needed to be done. ATI refers to this documentation as a work instruction, so it allows future assemblers to know exactly how to assemble the product. So I completed over 15 work instructions that had to do or focused on cable tie and spiral wrap locations within module housings. And then there were 2 work instructions completed, as you can see, like this one on the right shown here, that were specifically for pin block assembly instructions. So the impact of these work instructions is to help facilitate repeatable manufacturing in the future. So from this opportunity, I was afforded the ability to more fully understand the role that the manufacturing plays in the company's success. I think this is something that I had downplayed before coming to ATI, and being able to have this opportunity through the experience, I learned that manufacturing engineers are constantly troubleshooting problems on the assembly floor and developing tooling for more efficient product output. This highly relates to a company's success. Manufacturing engineers are often the ones that are solving the problems that make the production end of the company move forward and get product out the building, and really increase the sellability of product as they can reduce lead time through processes. So that process engineers are always analyzing new products, existing processes, trying to create more streamlined company standards and process instruction. Like you saw the work instructions that ATI creates for all their product, just trying to make things as repeatable, as sound, and as streamlined as possible. It's evident that ATI is very aware of the importance of the role that the manufacturing department plays in pleasing customers through shortened lead time. It's evident in the focus they place on addressing continuous improvement ideas and facility efficiency. The higher ups were always looking to move forward. They're encouraging continuous improvement ideas and always looking to address the request as they came to the table. So what did I learn from this experience? I did feel like I grew a lot professionally. I learned proper engineering documentation and practices through work instruction, through product testing, um, through product design and development, tooling design and development. I learned GD&T drawing standards, was able to take a course as well as have many different opportunities to test my or work on my GD&T abilities through creating multiple drawings for different tooling parts. Uh, my professional communication developed both verbally and written through things as simple as uh, emails to coworkers about product or about tooling, or conversation in meetings, or scrum huddles or things of that nature, as well as written as again the work instructions that were completed. And also grew in my knowledge for manufacturing production processes and possibilities for improvement. Um, so just understanding the need for those things, for always looking to improve on processes and how the manufacturing role plays a part in the company. So did this experience confirm or shift my career plans? In all honesty, this opportunity opened up a side of engineering in manufacturing that I really had never considered as a career path. Um, it did not shift my career plans, but it did show me that manufacturing engineering could be, exciting and challenging and something that I would like to do. Although I do still see myself following a more developmental design role than a process or manufacturing engineering role. That's the end of my slides. Thank you so much for taking the time to uh, watch this. I'm grateful for the opportunity I had at ATI, as well as UNC Charlotte's facilitation of this opportunity. Thank you.